All right, guys, welcome back. Are you guys excited for some more geometry? So what you're looking at here is pretty much a summary of what we did on Monday. So on Monday, we looked at the scaling principle for area. We looked at what happens when we scale something by a scale factor of r, right, like a dilation, so that the figures remain similar. And when we scale in two perpendicular directions by two different scale factors, let's call them A and B. So see if we can fill in the blanks here for a really quick warm-up. All right, so when we scale similarly, or when we dilate something, and we have similar figures by a factor of r, the areas get multiplied by a factor of r squared. And when we scale something in two perpendicular directions by factors of A and B, then its area gets multiplied by a factor of A times B, right? And usually the two perpendicular directions are going to be the horizontal and vertical directions. Cool? So this lesson, as it turns out, it's going to be a one-time lesson. I decided to head in a different direction. We're going to be doing circles now, actually. I think it was still worthwhile doing this lesson on Monday because there was a question on the take-home test, not take-home test, the remote learning test that a lot of you got wrong, and it dealt with this concept which we talked about earlier in the year. So it's just good to go over it and really just go over it in a little more detail. So that was what we did Monday. Today we are going to be looking at circles. All right, so today's going to be a lot of definitions. We're going to talk about arcs, central angles, and chords. All right, so first, let's start with the definition of a circle. So you might have written this down very early on in the year, but definition of a circle, it is the set of all points equidistant, right, the same distance away, equidistant from a fixed point. And what do we call that fixed point that all points are equidistant from? Very good, class. That is called the center of the circle, right? What's the definition of a radius? So geometrically speaking, what kind of thing is a radius? Well, a radius is a line segment. So that's how we're going to start the definition, right? A radius is a line segment from the center of a circle, from the center of a circle to any point on the circle, right? And when we talk about a point on the circle, let's look at this diagram here, right? Points on the circle are points P, M, and N, right? Anything that's on the circle. Right, so let's name all the radii of circle O here. So circle O, if I name the circle circle O, that means O is the center of the circle. So someone give me a radius. All right, OP, good. OM, yes, and ON. All right, very simple stuff. So OP, OM, and ON. Those are our radii. What is true about all radii of the same circle? We've talked about this many times, right? We know all radii are congruent. We've used that definition a whole bunch when we did constructions, right? To justify constructions, things like that. All right, what's the definition of a diameter? Well, geometrically speaking, what's a diameter? That is also a line segment. So this is a line segment whose endpoints, where are the endpoints of a diameter? Well, the endpoints are, both of them are on the circle. All right, so diameter, both endpoints of a diameter are on the circles. For example, there and there, right? So is that a diameter? Clearly not, what other condition does a diameter have to satisfy? It has to have endpoints that are on the circle and passes through the center of the circle. All right, so in this diagram, do we have a diameter? It would be NP. That is assuming, though, that NOP is a straight line, which they don't tell us, but I think it's pretty safe to say that NOP is a diameter or NP is a diameter. All right. So next, our big one, what is a central angle? So a central angle is an angle whose vertex is the center of a circle. An angle whose vertex is the center of a circle. So here's an angle, POM, right? The vertex of this angle is the center of the circle. So our central angle here would be POM, right? And there's the measure of that angle. And why don't you take a second and name all the central angles in the circle above. And there's a couple. So we have POM. Let's name them. We have angle POM. We also have angle MON, or NOM. Angle NOM. But there's some other interesting ones as well. So central angle, how about this angle, NOP? Right, that's a straight angle, that's 180 degrees. That's also an angle. Angle NOP. Right, but we could also talk about reflexive angles. Right, this angle NOM could also be talking about this angle. And that's going to come up a little later when we talk about arcs. That's more important. But typically, if we say angle NOM, we're always going to be talking about the angle that's less than 180 degrees. Right? The reflexive angle would be this one, though. Right? And same thing for angle POM. Right? That also has a reflexive angle that's more than 180 degrees. Right? This guy. Right? Any other angles in here? I think we're good. All right, so arc. An arc is a part of the circle. A minor arc is the part of a circle intercepted by a central angle less than 180 degrees, and a major arc is a part of a circle intercepted by a central angle more than 180 degrees. So for example, PM here, that is an arc. So is PM, is that a minor arc or a major arc? Well, that is a minor arc because it's intercepted by this angle here, which is less than 180 degrees. Right? But like we were talking before, angle POM could also be referring to this angle. Right? So if we're referring to that angle, well then, here is the major arc intercepted by angle POM. So one arc I have is PM, right? And PM would be referring to that arc. So how would we name this arc, the major one? So if we're naming a major arc, we're going to have to use 3 letters to show what direction we're going. So that is going to be P, N, M. That's going to be arc P, N, M. So for a major arc, you want to be using 3 letters. And anytime you use 2 letters, we're automatically going to default to the minor arc, right? Just like when we say angle POM, right? We're going to be talking about this angle that's less than 180 degrees, unless we specify right? That's more than 180, or we call it the reflexive angle. So similarly with arcs, if we talk about arc PM, that is the arc we're talking about. If you want to talk about the major arc, you have to specify P, N, M. So I know I'm going in this direction, or M and P. All right, so let's name all of the minor and major arcs in the circle above. So we got PM, PNM, we got NM, that's a minor arc. Put the minor arcs on the left here. We have, want to name it the other way, right? These two arcs make a full circle. We have NPM, that's a major arc. And again, 3 letters to name a major arc. Any other ones? Let's see, NNP, yeah, name that. Right. We also got 2 other arcs, NOP and NOP. So, sorry, no O, just NP and NMP. So those are formed by the diameter, right? So those are straight angles, those are 180 degrees. And just note that those angles are formed by a diameter. And it also splits the circle in half, and we call half a circle a semicircle. So diameter NOP splits the circle into 2 semicircles. All right, guys, so it's lab time. If you would like, or not if you would like, get out your calculators and follow those steps in the lab. All right, there's no time pressure here. You can pause the video and take as long as you need. All right, I do not have the calculator app on my computer, so I will be showing you on a trial version of Geometr Sketchpad. It's limiting me to 20 minutes, and I can't save documents on it, but 20 minutes should be good enough to show you what's going on here. So hold on, let me change the screen I'm sharing. Change it to this, all right. So hopefully you can see this. So in your calculator, construct a circle, construct a central angle. So you're gonna need another point on your circle. And I'm gonna connect Ooh, I'm sorry, excuse me. I'm going to connect those with line segments, like so. And let's measure the central angle. So you can click the 3 vertices, which make up, or the 3 points, which make up your angle. And I'll do the same thing here. So click, 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 measure this angle. So measure of angle ABC here is 63.41 degrees. And now we're going to measure the arc intercepted by the central angle. On your calculator, you're going to do this by highlighting the circle. All right, so you're going to click on your circle on your calculator, then highlighting the 2 points on the circle which contain the arc. Then you're going to click on these 2 points, right, which form arc AC, and you're going to measure that. So I'm going to be measuring the arc angle. And you'll notice the measure of angle ABC is the same as the measure of this arc. We can say the arc has a measure of 63.41 degrees, right? And so if I adjust this angle measure, you'll notice the measure of the arc in degrees is also the same, right? So it's kind of a different concept, but you can measure an arc by the number of degrees it has. And it doesn't matter how big or small your circle is, right? the measure of the central angle is always going to equal the measure of the arc. So that is, oh, I have to switch back to our notes. Share iPad, and I got to remirror. Give me 1 second. All right, and let me move this back to Zoom share. All right, so the measure of an arc is, the degree measure of an arc is equal to the measure of the central angle, which intercepts the arc. So if you have a circle, bam, this needs to be the center of the circle. Right? If this angle here, let's say this is theta degrees, right? Then that arc here is also a measure of theta degrees. And just be careful if you have an angle like this, let's say this is 40 degrees, right? We can't say that's 40 degrees because that's not the center of the circle. So this only holds for central angles, and central angles have their vertex at the center of the circle, right? Center. So if this here were 40 degrees, then we can say that is 40 degrees. Right, what is true about a central angle that is a straight angle? That is going to be 180 degrees. And like we were talking about earlier, right, if that's 180 degrees, then that is half the circle. That is a semicircle. And a diameter is also going to be forming that straight angle. Right, this is formed by a diameter, any diameter, right, is going to make a straight angle. And it's also going to form a semicircle. I'm going to change that word form to creates. That's going to create a semicircle. All right, so I think we all know how many arc degrees are there in a circle. Well, if there are 360 degrees in a circle, that means there are 360 arc degrees in a circle as well. Right, here's another good vocab word, a quadrant. Right, if you know from graphing, there's 4 quadrants. If that's our center of the circle, right, a quadrant is going to split up our circle into a quarter, and that's 90 degrees in the quadrant. So that is the degree measure of an arc, but we also have something called the length of an arc. So the length of an arc, or arc length, that's what we're going to be using. That is the measure of the distance along the section of the circle making up the arc. So let's take a look at this circle here. We have the length of AB is 5 centimeters. So this is 5 cm. And the measure of angle CAB is 60 degrees. All right, so what we can say is that the measure of CB is also equal to 60 degrees. All right, that's notation for arc degrees, or the degree measure of an arc. We use the letter M. But if you want the arc length refers to the actual length of CB, right? And you can use a L for the length of CB. This is length. Right. Actually write it for the other one also. I guess. Right, this refers to the degree measure, and this refers to the length, right, or the arc length of CB. So how can we find the arc length of CB? Well, the way I like to do it is by setting up a proportion. All right, so let's do another example first, and then we'll go back to that one real quick. Let's say we had a circle, and let's say the circumference, let's say that was equal to, let's make it really easy, let's say 10 units. All right, so the entire circle, the perimeter of the circle really, right, that is 10 units. So I think you guys would all be fine if I split the circle in half and I said the length of this arc here would be 5 centimeters or 5 units, right? And if I split this up into a fourth, if I gave you this quadrant of the circle, I think you'd all be happy saying that was 2.5 units or a quarter of the circle, right? So it really all has to do with the central angle. If this were 60 degrees then, well, what portion of the circle is that? Well, I know the entire circle is 360 degrees, right? That's going to be 300 degrees, but the entire thing, that's 360 degrees. So this arc over here, right, the length of that arc is going to be in the same proportion as this degree measure to the full 360 degrees of the circle. In other words, 60 degrees is 1/6 of the circle, right? Because 60 over 360 degrees is 1/6. So the proportion I could set up is, well, 60 degrees goes with this arc length, let's call that x, and 360 degrees, that corresponds to the entire circumference of the circle, which is 10. Right, so you can set up a proportion like this. 60 over 360 is equal to x over 10. So solving for x, right, we get 60 over 360 is 1/6. Right, 1 over 6 is equal to x over 10. And so we're just going to take that circumference of 10 and divide it by 6 when we cross multiply. Right, it's going to be 10 over 6. So we can do the same thing for our example up here. Again, I know this is 1/6 of the entire circle. You would get that by setting up this ratio, 60 to 360. So now that 60 degrees, that is going to correspond with our arc length of CB. So the length of CB over the entire circumference. And how can I find the circumference? Well, circumference of a circle is equal to 2 pi r. So circumference here is going to be 2 pi times 5, which is 10 pi. And 1 over 6 equals that if you want to reduce that fraction. And I can say the length of CB, or the arc length of CB, is 10 pi over 6. All right, so that is the difference between the degree measure of an arc and the arc length of an arc, right? The arc length measures the actual length of it, but you can also measure arcs in degrees and just say CB is 60 degrees. All right. So I'm actually going to go back to Geometry Sketchpad for a sec, because I want to show you, in general, a formula we can use to find the arc length. So let me pop back here. Please move this window from the shared application. All right, hopefully you can see this now. So let me measure Is it sharing? I don't know what's going on. Let's close that. Remove this here. All right, I don't know if it's sharing or not. Resume share. All right, hopefully it's sharing. All right, so if I want to find the arc length of AC in this diagram, right, I can measure AC like that and measure the arc length. So the arc length here is 3.86 centimeters. And you can see as I adjust it, and just like what we were talking about before, it's always going to measure the minor arc. So you'll notice it doesn't keep increasing once I go past 180 degrees, right? It starts measuring this side now, right, for AC. And it's over here, it's going to measure that for the length of AC, right? And again, we see the measure in degrees of the arc over here and the actual length. Like if you pulled up a string and pulled it around and you measure the length of the string. All right, so let me measure this length. That's our radius, right, 3.79. And I'm also going to measure the circumference. So the entire circumference is 23.8 centimeters. So like I was saying before, we can set up a ratio using the central angle. So if I go to, where is it, calculate, right? I'm going to calculate the central angle. And what am I going to divide that by? I'm going to divide that by 360 degrees. All right, why do I do that? Because, good, there are 360 degrees in a circle. So that's the proportion this arc length is of the circle, right? And then I can multiply that by the circumference, right? And that should give me 4.47, which is the length of the arc, right? And you can see as I adjust this calculation here was equal to the arc length. So all I did is I took the central angle, I divided by 360 degrees and multiplied it by the circumference, right? Because the circumference goes with all 360 degrees of the circle. And I'm just getting the fraction of the circle that I'm interested in, right? So what fraction of that circumference am I interested in? I'm interested in this case, if I make it, let's say 90 degrees, I get really close to 90 degrees, right? I'm interested in 1/4 of the circle, or 90 over 360 degrees. So that's just the circumference divided approximately by 4, or I'm trying to get close to 90 degrees. So hopefully you guys can see that. 23.8 divided by 4 is 5.95, right, etc. So let me go back to my iPad. And I'm sorry about switching back and forth, but it's really the best way I have right now of showing you guys. All right. So we want a formula for arc length. We can say formula for arc length is arc length is going to equal the measure of the central angle over 360 times the circumference. There we go. So you can use this formula if that makes sense to you, or you can just set up a proportion, and that's the way I like to do it. Doesn't matter how you do it though. All right, so pause the video and try example number 1. But wait, before you do that, I do not have a licensed version of MathType, so I couldn't draw the arc symbols. So these are supposed to be arcs over here. All right, so based on what we just did, given that BOD is a line, find those measurements of those angles and find not the arc lengths, but the arc degrees, right? The measure of the degrees of those arcs. All right, so real quick, BOA, if I know my intercepted arc has a degree measure of 90 degrees, then I know the central angle, that's also going to be 90 degrees. So that is 90 degrees. Good job. BOC, same idea, intercepted arc 40 degrees, or central angle that makes up the intersected arc is also 40 degrees. All right, AOC, 90 plus 40, that's 130 degrees. And COD, well, they told us BOD was a straight line. That means BOD is a diameter because it passes through the center of the circle at up. Right, so COD is going to be, that's 40. This is a straight angle. So that's 180 total. So that will be 140 degrees, right? 180 minus 40. Now let's find the measure of arc AC. So this arc was 90 degrees. This arc is 40 degrees. Altogether, this arc measures 130 degrees. But what's the measure of arc DC? Same thing as the measure of the central angle COD, which is 140 degrees. And what's the measure of angle ABD? Sorry, not the measure of angle ABD, but the measure of arc ABD. ABD. So that's going to be 270 degrees. And hold on, I want to check something real quick. Yeah, that's 270 degrees. And I'm sorry, these were supposed to be arcs, so there should be no angle symbol here. Right, I'll make sure to take that out in your version of the notes, right? But I don't know if I can get these arc symbols in, right? So there should be little arcs above those. Cool. And just one more quick one. If we're looking for arc length, let's say the diameter or the circumference here was given by this radius. Let's make the radius 4. All right, let's find the arc length of, let's do AC. All right, what's the arc length of AC? So AC, that's 130 degrees. So the proportion of the circle, or the fraction of the circle it makes up, is 130 over 360 degrees. And all we have to do is multiply that by the circumference. So the circumference, we have a radius of 4, circumference is 2 pi r. So that's going to be 8 pi for the circumference. And just type that into your calculator, but ask you to round to the nearest whatever, round to the nearest whatever. But I'm going to get the exact answer here. All right, and give me a sec to see what that is. Start graphing. 130 over 360 times 8. And degree again. It's 2.8 repeating. All right, let me get that as a fraction. Sorry. Da-da-da. 130 divided by 360 times 8. All right, or we can also say 26 over 9 pi. And that's the nicer way to write it. There we go. So I think I'm actually going to hold off on chords today. We'll save that for the next lesson. So we're going to stop here. So nothing too crazy today, I hope. Just some definitions. Main idea is this right here. The degree measure of an arc is equal to the measure of the central angle which intercepts the arc. And also the converse statement of that, if you know the measure of the arc, right, you also know the measure of the central angle that makes that arc. So vice versa. And this definition of arc length and how to find the arc length by either setting up a proportion or you can just use this formula. All right, so that's going to be it for today. See you guys next time and take care. Stay safe. All right, I forgot I don't end the video from there. I got to end it on my computer. All right, bye guys.